Hey, Nicholas JMV here. Video 2 on net change as the integral of a rate. In this video, we're going to be taking a look at the integral of velocity. So when we're looking at velocity, it's first derivative, right? So the integral of velocity for an object in linear motion with velocity v of t that's following two things we know. The displacement, which is called net change, over that interval t sub 1 to t sub 2 is equivalent to the integral of t sub 1 to t sub 2 of v of t dt. Okay, the total distance, the distance traveled during this interval from t1 to t2, t sub 1 to t sub 2, is the integral of t sub 1 to t sub 2 of the absolute value of v of t, and we're taking that integral with respect to dt. Okay, so let's look at an example that shows both, and this is coming out of Rogowski. Okay, good textbook. So the particle's velocity is given by this formula. Compute the following: the displacement or net change over the interval 0 to 6 and the total distance traveled over that time. So we've got a little bit of work to do. Okay, so the displacement, okay, we're going from 0 to 6. So we're going from 0 to 6 of v of t dt. Okay, so we're going to go ahead and calculate that. So the integral from 0 to 6 v of t is t cubed minus 10t squared plus 24t and that's integrating with respect to dt. Now that integral ends up being t to the fourth over 4 minus 10 over 3 times t cubed plus 12t squared. Okay, and we're going to evaluate that from 0 to 6 on the interval. We don't need to plug in 0 because 0, 0, it's all gone. So when we plug in 6 and simplify, we get 36 meters. That's the net change over that interval from 0 to 6. Now, part B, the total distance, is a little more challenging. We know that v of t, if you factor this, is t times the quantity t minus 4 times t minus 6. If you look at the sign analysis of this at 0, at 4, at 6, anything between 0 and 4, positive number, right? So positive number, if anything's less than 4 here, it's going to be negative. Anything less than 4 is negative. So negative times a negative is a positive. So this is positive. But from here, it's negative. So in order to do this integral from 0 to 6 of the absolute value of v of t dt, I'm going to have to split this up into two integrals. I'm going to have to say, okay, from 0 to 4 of v of t dt, and I'm going to subtract off from 4 to 6. I'm going to subtract off a negative area, which makes it positive. Okay, so that's how I can handle that negative area. That graph is going to be below the axes, so it's just v of t dt. So I have to do two integrals. Okay, so basically what happens is from 0 to 4, my one integral is going to be of t cubed minus 10t squared plus 24t dt. I'm going to subtract off that second integral from 4 to 6 of that same function. We already have the integral. We already integrated. It's over here. There's your integral. Okay? And so what we have to do now is go ahead and integrate each one of these. So we're going to go from 0 to 4. So we're going to have t to the fourth over 4 minus 10 over 3, t cubed plus 12t squared. That's going from 0 to 4. That equals, when you plug in 4, I get 128 over 3, and that's meters. From 4 to 6, okay, I get t to the fourth over 4 minus 10 cubed. 10 over 3 t cubed. I keep saying that. And here we're going from 4 to 6. Now this time I got to plug in both. When I plug in 6 and I subtract off the plugging in 4, I get negative 20 over 3 meters. So if you take 128 over 3 meters minus negative 20 over 3 meters, you get 148 over 3 meters. okay? Or you can say 49 and a third. It's approximately 49 and 1/3 meters. That's the total distance that particle traveled over that time interval from 0 to 6. So if you have any questions or comments on how to use velocity and in relation to net change, you can go ahead and type your questions below, and we'll see you next time.